Progress.
Okay, today we are going to be talking about what's known as the difference quotient. Okay, and the difference quotient is a little interesting twist on the slope formula. Okay, it looks like this. You take your function, whatever it is, f of x, and you make it f of x plus h. So you plug x plus h in for the x. And then you subtract your function and divide it by h. I'm going to show you how that's a twist of the slope formula. And this leads into calculus into what's known as the derivative. So here I've got this curve. And I've got 2 points on this curve. In the past, we've called them x1, y1. And x2, y2. And between these 2 points is a line known as a secant line. And that secant line is the average rate of change between those 2 points. You're going to start seeing this formula for average rate of change with the points notated as A, f of A, f of A just being the y coordinate that goes with A, and B, f of B. And so we have this old slope formula, M. You've been using this since middle school. Well, oops, x1. If I change to my blue variables, not sure what that arrow is about. Not sure how I got that. Anyways, just ignore that downward arrow. It won't erase. Let's see if I can undo. Okay, there we go. So you'll see that formula, and that just means slope between the lines. Now's where it gets real interesting. We're going to call this x f of x. This is where the difference quotient comes in. And we're going to call this distance here, whatever this horizontal distance is, h. So the second point, my x coordinate becomes x plus h. And my y coordinate is just f of my x coordinate, f of x plus h. So I took my x coordinate, I added h to it, and that gives me my new x coordinate. What we're ultimately going to do is you lead to this thing called and we're not going to do this until calculus. You do this limit as h approaches 0. So basically, you're squishing the 2 points, you kind of bring them together. You're squishing them together as h goes to 0. and that's known as the derivative. And so the derivative gives you the slope of the line at that exact point. It's known as the tangent line. So we're going to work with the difference quotient. I'm going to show you just a second how this formula works out from the slope formula. That's called the tangent line. So the slope formula for the first one, y2, minus y1 over x2 minus x1. My x's cancel out, leaving me with the difference quotient. Now, working through the difference quotient, I'll go through a couple examples. But that's how you get the difference quotient. It's literally just the slope formula. And we're going to work through it to show how, because when you're doing this derivative, you need that h from the bottom to cancel because you're dividing by 0. That's a problem. So you got to work through the difference quotient to make it cancel. I'll leave the difference quotient visible. That's this. So we're going to use that with a function. And I'm just going to call my function g of x. We'll start with a pretty simple one. So now to plug into the difference quotient, g of x is 2x squared. So g of x plus h is 2x plus h squared. So I've taken care of my first term here. Taking care of that part. Minus g of x. I just plug in the thing. That's my second part here. And finally, just h. I have now plugged into the difference quotient. And I'm going to start simplifying. I'm going to multiply x plus h times x plus h, foiling my shortcut that I'm using. If you don't know the shortcut, you just write out x plus h times x plus h, and you FOIL. The shortcut is square the first and the last. The middle one is 2 times the things x and h, the two terms multiplied together. Sorry, didn't mean to make that move. Anyways, it still works, I guess. Doesn't want to move back. 2x squared all over h. Giving me, now I'll distribute the 2. 4xh plus 2h squared minus 2x squared over h. Notice my first and last term. 2x squared and negative 2x squared. Those add to 0. Giving me 4xh plus 2h squared over h. And I told you I wanted the h from the denominator to cancel. I cannot cancel the h in the step above. I can't just cancel it from one. I have to cancel. It must be in every term. Because equivalently, this is like saying 4xh over h. When I add fractions, I must have a common denominator. So I can split that apart. I can just add them together. So the h must be everywhere. I'm going to cancel one of those h's, not the h, but h squared is h times h. So I'm only canceling one, giving me a final result of 4x plus 2h. Okay? And that is my difference quotient for the first one. This is your answer. If I were talking the derivative, it'd be 4x, but we're not talking the derivative. That is what my difference quotient looks like. There is a question like this on your midterm. It's a few questions on your worksheet. Okay, we're going to do one more. Okay, I'm going to write the difference quotient again because I can't keep it on the screen. This is actually given to you on the midterm. That what the difference quotient is. You just have to be able to use it. So my function here will do, not equals. My function is going to be h of x. I want a new letter this time. Okay. To do my f of x plus h must go in for both x's. That's my f of x term. All I've done so far is the f of x term. Now I'm doing the minus. No, sorry. All I've done so far is the f of x plus h term. Say that again. This right here goes with that right there. Okay, I'm going to undo those so I get rid of the lines. Now I'm onto the f of x term, which is literally just plug in what my initial function. But it's important that I use parentheses because I have to distribute that minus sign. Okay, now it's time to simplify. And again, I'm foiling x plus h squared, and I'm distributing the negatives. Well, I want to save a little writing. Minus 3x and plus 3x are going to cancel. So now I can get rid of that. Now it's time to distribute the 2. And before I can start canceling h's, every term on top has to have an h. But those two, 2x squared and negative 2x squared, also cancel. If everything doesn't cancel, so you only have terms with, so everything on top ends up with an h, you did something wrong. Okay. Now again, now everything on top has an h. So I can cancel one h from each term. That does not cancel the entire h squared. I'm not left with just a squared. I'm left with an h. giving me 4x plus h minus 3. That is the solution to the difference quotient. You need to try some and practice these because it doesn't make sense until you start doing it.